Yeah, hello. Let's look at the classification of partial differential equation. So first, we are going to look at the first order um, PDs. Okay, how you can classify them. So these are the four things you are going to look at: the homogeneity, the order, the scalar or the system of equation. This one I won't waste my time on them because scalar equation, the system of equation, right? Like for the system of equation, like the simultaneous equation and those stuff, you know them. Then you also look at the linearity of them. So the ones I'm going to deal with is the 1, 2, and out of the 4. For this one, it's not important for me. Now let's look at the homogeneity. Let's take the function of this is equals to this, where this is the differential equation or the principal part, okay? And this is the function part. So if the principal part is equals to this, now how would you know that it is homogeneous or is non-homogeneous? It will be homogeneous when this part is not there, or in other words, when this part is equals to 0. When the function part is equals to 0, then it becomes homogeneous. But when the function part is not equals to 0, then it becomes, sorry, I beg your pardon. When the function part is equals to 0, that's what I said, right? Then it becomes homogeneous. That means when there's nothing here, it becomes homogeneous. Then when the function part is not equal to 0, it becomes non-homogeneous. So let's look at an example. What do you mean by the function part? You see, this is the principal part. This is the differentiable part. This is not differentiable, or it has not been differentiated. So this is the function part. This is the g of x or the f of x. So this one is still there. So this is classified as what? Non-homogeneous, because this side is not 0. If you look at this one too, this is the principal part, this is the function part. So the sine x, if I send it here, it becomes negative sine x. Don't say that this side is 0, so it becomes homogeneous. No. So this sine x is here, it's not differentiated. So it is what? Non-homogeneous. This is principal part, this is non-principal part. So this is what? Also non-homogeneous. Let's look at the homogeneous. You could see that this is principal part. The f of x, or the function part, or the non-principal part is 0. It's there, we don't have anything like that. You could see that. So this is the homogeneous. When these ones are 0, or when the g of x, y is 0, then you call it what? Homogeneous. So you should take note of that. So please, you should understand this thing, because you can be asked to classify them in your exams. Okay. Now let's move on to the other. Okay, now let's look at the other. The order of PDE. In fact, this is similar to the ODE, because for the order of PDE, we only look at the highest derivative. Okay, so let's say when you take this one for instance, this one means we have differentiated once. We have differentiated this one once. So what is the highest here? It's 1. So this will be what? The first order. Is that okay? If you look at this one, this has been differentiated how many times? 2 times. That's why we have 2 tt. This has differentiated 2 times. But this is power 4. Now, you should not confuse yourself with the power here. This is just a degree. This is the order. We just look at the one here, the subscribed one. Okay, the subscript. This is the subscript x. This is subscript t. And this one is having 2. This is having 2. So the highest order here is 2. So this will be the second order. Now this one, this is having subscript 2, this is having subscript 3. How many? So which one of them will be the highest? This one means you are differentiated 2 times, 3 times. So the one with 3 times will be the highest order. Is that okay? So the order is 3. So if the question asks you, state the order, you don't state this, the 2, and write second order. No. The highest order is the one with the highest, or the order is the one with the highest, sorry. Okay. Now, if you look at this one, this is x. Though it's with power 5, this is power 6. These are degree. That's not determine anything. You only look at the subscript. This is having 1, 2, 3, 4 subscript. This is having 3. This is having 1. So the highest order here is what? 4. So it's order 4. So that is all. That is all. I won't go much about this one. That is all. Okay. Now let's look at the linearity. I've already said I won't talk about the scale. That one is simple, so I won't talk. All right, so now you are seeing a lot of tests on the board, and we are looking at the linearity of PDE. A PDE is said to be linear if it meets the following conditions. So if these conditions are not met, become nonlinear. Simple as that. Okay. One, and here everything is going to be focused on the dependent. Nothing has to do with the independent. So one, the dependent variable and or its derivative occur to the first degree only. So the dependent variable and its derivative occur to the first degree only. So if the dependent variable does not occur to the first degree only, it becomes how do you call it? Non-linearity. There is no product of the dependent variable of and of its derivative. You can't get dependent variable and of its derivative. So you cannot get something like x, something like this. If you get something like that is wrong. That becomes non-linear. Okay. Then there is no transcendental functions of the derivative, the dependent variable and its derivative. So the transcendental function, you can get the trigonometric function, you can get the exponential function, and the logarithmic function. They are all transcendental functions. So let's look at example. If you look at this one, this is ux plus 3uy equals what? 2. So the dependent variable is occurred to what? The first degree only. What do you mean by the degree? Here is power 1. Power 1. If it was like ux all to the power 2, this is becomes non-linear. So the first degree here is occurring to degree 1 only. Secondly, we are saying that there's no product of its derivatives. Okay, so there's no product of the dependent variable and its derivative. So there's no product of such, and there's no transcendental function happening on the dependent variable. So this is what? Linear. Linear. Okay, now let's look at the 2. Ux plus 3uxy plus this cosine xy. So will this one be linear or non-linear? This will be linear because there's no product of the dependent and its derivative. There is no transcendental function. I've already said this sine xy, there's no dependent variable there. You can see that it's only sine xy, there's no u there, so you can't add it. We are only focused on the dependent variable, which is the u here. Okay, so yeah, so this one will also be treated as what? Linear. Okay, let's look at the second one. The second one, the degree here is what? 2. So automatically I won't even waste my time. It's non-linear because it said that the dependent variable and its derivative occur to the first degree only. So if the degree there is more than 2, more than 1, it becomes non-linear. So this is non-linear. When you say degree, we are talking about the power. Now, this one too is non-linear because of the u squared here. This is sine u plus e to the power u. Now, which law is this one violating? Is this one? There is no transcendental function of the dependent variable. So if you look at this dependent variable, which is u, there's a transcendental function there. Apply on the u. So you see the difference between this. There's no u here. Can you see that? But the difference there is that here there's a transcendental function on the dependent variable. There's a transcendental function on the dependent what? Variable. Okay, now let's look at the last one. Is with degree 1. There's no product of the dependent and its derivative. There's no transcendental function on this. This is a transcendental function, that's the exponential function. But there is no dependent variable there. So this one also becomes what? Linear. This is what? Non-linear. Is that okay? Very good. Okay, now let's look at non-linearity. The non-linear PDE can be classified. So you see, we looked at linear 1. For the non-linear, it can be classified under 3. One is semilinear, quasilinear, and the fully nonlinear. Okay. Now let's first look at the semilinear PDEs. The first order nonlinear PDE in which the nonlinearity is only in the unknown function. Okay. What do you mean by the unknown function? You see, if I write this view like this, it's an unknown function because I don't know whether I'm going to differentiate partially with respect to x or y. So it's an unknown function. So if you look at all this one, the unknown function is this one. Also, let's say we are dealing with this is first order. If it's second order, like if I have uxx plus uy, something like this. Though this is differentiated partially with respect to y, but when it comes to this case, this becomes unknown function because the highest order here is second order. So we wouldn't know that this one, the second order of this, will be whether we are differentiating with respect to x or y. Do you understand what I'm trying to say? So the unknown function does not necessarily mean that it should be just u. No, it depends on the order. This is first order, so the it unknown function will be u, but second order it unknown function will be u subscript x or y. So here you could see that the transcendental function or the nonlinearity is happening here because of this transcendental function. It's happening on the unknown function. Now, if you look at this one too, this one is linear, this one is linear. There's no nonlinearity on this. There's no product of a function and its derivative. There's no product to a dependent on its derivative. There's no degree of 2 or 3 or more. There is no transcendental function on this. But if you look at this one, the transcendental function is on this u, which is what? Unknown function there. If you also look at this one here, the same thing, the non-linearity is happening on this u. Is u squared, it's supposed to be u power 1, but it's squared now. So the non-linearity is happening on this. That makes it what? Semi-linear. So you should understand the semi-linear very well. This one is very tricky. The semi-linear is when the non-linearity occurs on the unknown function. In this case, the u here, the one without the differentiable. But even if you are talking about the second order, then think about the first ones, the first order as your unknown function. That's what I want you to understand. Okay, now let's look at the quasilinear. Okay, a partial differential equation is said to be quasilinear if it is linear with respect to all the highest order derivative of the unknown function. So what you are just trying to say is that when you have a product of a higher derivative and unknown function, then it becomes quasilinear. When you are multiplying a higher derivative with unknown function, it becomes quasilinear. And also mind you, when the quasilinear and semilinear meet in a question, the answer becomes quasilinear. Also, let's see this. So when I take this and that, it becomes quasilinear, okay, because this is a higher derivative multiplying unknown function. So this also becomes quasilinear, but this is a higher derivative multiplying this unknown function. So you should take note of that. Because you are dealing with first order, that's why I don't want to be bringing it in. But as you be going, some question will be coming and it will be looking like this. Okay. So here, ux, okay, is multiplying this. So this and that, you see there is a product there. That makes it quasilinear, okay. And even this and that, there's a product that makes it quasilinear. When it comes to this place, if not because of this, this becomes semi-linear because the square, the non-linearity is on the unknown variable or function. But if you look at this one too, there's a product between the highest order and the unknown function. So this makes it quasilinear. Then this is semi-linear. They are meeting in one question. So your answer should be quasilinear. So when the quasilinear meets the semi-linear, it should be quasilinear. And also, see this is multiplying this, and this is unknown function. It doesn't matter, there's a square here which is making it semi-linear, but this is unknown function multiplying a higher derivatives. That makes it what? A quasi-linear. Is that okay? I hope you understand the quasi-linear now. I'm moving fast, don't worry, because of my time. So that is the quasi-linear. Now let's look at the last one. That's the fully nonlinear. Fully nonlinear. Okay, lastly, we look at the fully nonlinear. PDE is fully nonlinear if the highest order derivative of u appear nonlinear. So when you have a question like this and you just check the highest order, so here the highest order here is this and that, and you see that it's appearing nonlinear. So this become fully nonlinear. Even if you have u squared x plus this, and this one too is equals to 0, you could see that the highest order here is appearing what? Nonlinear. This one too is appearing nonlinear. This makes it semi-linear, but when nonlinear meets semi-linear, it's still fully nonlinear. When fully nonlinear meets quasi-linear, it's still fully nonlinear. You should take note of that. So if you look at it, this is what? Fully nonlinear. Now, here, what is the highest order here? This is the highest order. And why is it nonlinear? Because there is a product of two derivatives. Have you seen that? So that makes it non-linear. And this becomes fully non-linear because the non-linearities occurring on the highest order. This and this, the highest order will be this. This is unknown function. The non-linearity is the transcendental function. Ln is occurring on this highest order, which is ux. Is that okay? The same thing applies to this. Look at something here. If I have u x power 4 plus ux equals 0. This is fully nonlinear because the nonlinearity is occurring on the highest order. Is that okay? Very good. So please try to look for more examples and solve it. Now let me explain something here again. You look at semilinear. You also looked at the quasi-linear, then nonlinear, where you said that semilinear is when the nonlinearity, okay, nonlinearity occur on the unknown function, and the quasi-linear is the product of the higher order and that of the unknown function, and that the fully nonlinear is when the nonlinearity occur on the highest order. So you should take note of this. Understand this one clearly, and it's very, very important. I know why I'm saying that. Understand it, because when it comes to exams, it's very, very confusing. Thank you very much for watching. Try to subscribe and share to your colleagues.